So hello everyone, welcome to another lecture video of the DOST Scholarship Online Exam Review offered by the VSU DOST Scholar Society. So I am Jotham Lloyd, Alegre, a third-year Bachelor of Science in Chemistry student from the Visayas State University. And for this video, I'm going to be your lecturer. So in this video, we're going to talk about Earth bending. Just kidding, Earth science. So Earth science is concerned with the solid Earth, its waters, and the air that envelopes it. It includes the geologic, hydrologic, and atmospheric sciences with the broad aim of understanding Earth's present features and past evolution and using this knowledge to benefit humankind. So Earth science has 4 subtopics. First is oceanography. This studies about the physical and biological aspects of the ocean. Next is meteorology. It is the study of the atmosphere that focuses on weather processes and forecasting. Next is astronomy. It is a natural science that studies celestial objects and phenomena. And last but not the least is geology. It is the studies of the Earth's physical structures and substances. So before we proceed to the lecture, I'm going to share you some tips on how to answer this part of the exam. So first is to familiarize. Having a deep understanding of the topics discussed is more important than just memorizing it word for word. Next is recall basic concepts, because most of the questions asked in this part of the exams are already discussed in the previous years of your Earth science lessons. So by recalling the concepts, it will be of great help to you in answering the exams. The next is be time conscious. Yes, you should always be time conscious when answering the exam since the time given is short. So are you ready? Let's start. So question number 1. An object with what looks like a tail is visible in the sky. What object is this? A. Asteroid, B. Comet, C. Meteor, or D. Meteoroid? So feel free to pause the video to answer the question. So before we answer the question, let us first define each choice. So first is asteroids. Asteroids are rocky worlds revolving around the sun that are too small to be called planets. They are also known as planetoids or minor planets. Next is meteors or meteoroids. Basically, they are the same. So a meteoroid is a small rocky or metallic body in outer space. When meteoroids enter Earth's atmosphere at high speed and burn up, they are called meteors. Next is comets. Comets are celestial objects consisting of a nucleus of ice and dust. When near the sun, it has a tail of gas and dust particles pointing away from the sun. So with that, the answer to the question is B. Comets, since comets have tails of gas and dust particles pointing away from the sun. So question number 2. Energy within the oceans is distributed through which process? A. Conduction, B. Convection, C. Radiation, or D. Refraction? So before we answer the question, let us first define the choices. So first is conduction. So conduction is the transfer of thermal energy through direct contact. So in this case, there is a direct contact between the sand and the shovel. So thermal energy can be transferred from the shovel to the sand or from the sand to the shovel. Next is radiation. So radiation is a method of heat transfer that does not rely upon any contact between the heat source and the heated object. So in this example, the heat source is the sun, and the heated objects are anything under the sun. So heat transfer in this example is called radiation. Next is refraction. Refraction is not a method of heat transfer. So instead, refraction is the change in direction of a wave passing from one medium to another caused by its change in speed. So in this example, the wave that passed through the water is light. So when light passes through water, its direction changes. So in this example, when the light passed through the medium, which is the water, its direction changes. And lastly is convection. Convection is the transfer of heat due to the bulk movements of molecules within fluids, including molten rock. This results in the continual circulation of ocean water on a global scale. So now that everything is defined, let us now answer the question. So, what is the energy within the ocean distributed through which process? So, looking in the definition, we can conclude that the answer is convection. So next question. Question number 3. The moon is very hot on the side facing the sun and very cold on the dark side. This extreme temperature difference is primarily due to the moon's A. Mineral composition, B. Thin atmosphere, C. Reflective rocks, or D. Lack of volcanic activity. So before we answer the question, let us first examine these conditions of the moon. So the mineral composition and reflective rocks cannot affect the moon's temperature. There are only two possible factors that can affect the temperature. This is the lack of volcanic activity and the thin atmosphere. So volcanoes can affect the temperature. However, the moon lacks of it. Thus, the lack of volcanic activity is not the answer. So, the answer is the thin atmosphere. So, unlike the Earth, the moon has a very thin atmosphere. Because of this, the heat given off by the sun cannot be trapped, thus making it extremely hot at day and cold at night. So to answer the question, the moon is very hot on the side facing the sun and very cold on the dark side is because of the moon's thin atmosphere. So let's proceed to the fourth question. Earth's atmosphere is divided into layers that are based upon their A. Water content, B. Relative humidity, C. Gas content, or D. Temperature. So before we start answering the question, let us first examine these choices. So Earth's atmosphere is divided into 5 layers. First is the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. So defining the choices given, the water content or humidity are the same. So humidity is the concentration of water vapor present in the air. It is dependent on the temperature. So based on the definition given, water content or humidity is dependent on the temperature. So it is not the answer since this is dependent on the temperature. Next is gas content. So gas content is the total content of gas and the gas composition of the atmosphere. So it is given that each layer has almost the same gas composition such as oxygen, nitrogen, argon, etc. So we can say that gas content is not the answer. So lastly is the temperature. So temperature is the degree of heat that is present or observed in an object or a material that can be measured using a thermometer or sometimes just with bare hands. So the different layers is categorized by their temperature. So the troposphere is much warmer and the exosphere is colder as it gets. So based on this, we can conclude that the answer is temperature. So to answer the question, Earth's atmosphere is divided into layers that are based upon their D, temperature. So next question, question number 5. So a total solar eclipse was last seen in the Philippines on October 24, 1995. Which of the following images shows the correct configuration of the Earth, Moon, and Sun during that time? So look at these choices carefully. So feel free to pause the video and examine the images carefully. So to answer the question, let us first examine these illustrations. So first choice is this. The Sun is between the Earth and the Moon. This is an impossible thing to happen since the Moon should be revolving around the Earth. This setup is impossible. So the next choice is this. The Sun is still between the Moon and the Earth, and the Moon is still not revolving around the Earth. So this is still an impossible thing to happen. So next setup is this. The Earth is now between the Sun and the Moon. So this setup is called a lunar eclipse. So a lunar eclipse occurs when the Moon moves into the Earth's shadow, such as this setup. So next setup is this, or what we call as the solar eclipse. So the Moon is in between the Sun and the Earth. So a solar eclipse occurs when a portion of the Earth is engulfed in a shadow cast by the Moon, which fully or partially blocks sunlight. So with these illustrations, we can now answer the question. So a total solar eclipse is set up like this. So the answer to this question is letter D. So the Earth, Moon, and Sun should be aligned like this. So let us now proceed to the next question. Question number 6. You observe that when you are looking at the front of your house at 8 a.m., the Sun is to the right of you. Returning to the same exact spot at 4 p.m., you notice that the Sun is now to the left of you. At which direction were you facing at 8 a.m. and 4 p.m.? A. North, B. East, C. South, or D. West? So to give you a visual representation of the scenario, let us look at this illustration. So it is said that at 8 a.m. in the front of your house, you notice that the Sun is to the right of you. And looking back at 4 p.m., the Sun is now to the left of you. So which side are you facing? So to answer this, let us look at the compass. So you notice that the Sun at 8 a.m. rose to the east side of you, and at 4 p.m. it set at the west side. So looking at the compass, you can conclude that you were facing north at 8 a.m. and 4 p.m. So to answer the question, at which direction were you facing at 8 a.m. and 4 p.m., the answer is north. In addition, you can also consider that the Sun always rises on the east side and sets on the west side. So with that, you can also conclude that the answer is north. So proceeding to the next question, question number 7. A mixture of sediment was placed on the closed-edge table. The faucet was turned on and allowed the sediment to flow downward. The sediment began forming at the lower end until a delta plane is formed. Using the illustration given, how can a delta be formed without excessive mass movement? So, condition A, turn on the faucet with water running smoothly and adjust the table on a low slope. B, turn on the faucet with water running smoothly and adjust the table on a high slope. Choice C, turn on the faucet with water running turbulently and adjust the table on a low slope. 3D, turn on the faucet with water running turbulently and adjust the table on a high slope. So feel free to pause the video and examine the illustration and the choices given. So, before we answer the question, let us first define what is a delta. So a delta is a landform created by a deposition of sediment that is carried by a river as the flow leaves its mouth and enters slower moving or stagnant water. Delta formation is affected by the velocity of the water and its slope, climatic conditions, geologic setting, tectonic stability, among others. So in this illustration, this is a delta. So it is a sediment deposits. So looking at the conditions given in the choices, with a high slope and a turbulent running water, sediments will be washed away instead of being deposited. Thus, no delta planes are formed. In a low slope but a running turbulent water, although the slope is low, the velocity of the water will wash away the sediments. The next condition is high slope and smooth running water. So due to the high slope, the sediments will still be washed away instead of being deposited. So there is still no delta plane formed. So in the last condition given, with the low slope and the smooth running water, so this is the perfect condition for delta formation. Sediments will be deposited instead of being washed away. So given the conditions, we can now answer the question. So, looking at the choices, we can conclude that the answer is letter A. Delta can be formed by turning on the faucet with water running smoothly and adjusting the table on a low slope. So now that it is settled, let us proceed to question number 8. So question number 8. You come across a fossil that is believed to be petrified wood. You are curious to know how old this fossil is. What dating technique will you use to know the age? So A. Relative dating superposition. B. Relative dating fossil succession. C. Absolute dating carbon dating. Or D. Absolute dating potassium argon dating. So to answer this question, let us first know the difference between relative dating and absolute dating. So relative dating and absolute dating. So relative dating allows for identifying the sequential order of geological events, one relative to the other. This is usually used in arranging geological events. For absolute dating, so absolute dating is based on the calculation of half-life. It gives numerical dating to rocks and other fossils. So let us first talk about the principles of relative dating. So it has 5 principles. First is the superposition. This principle tells us that the lower the layer, the older it is, and the higher the layer, the younger it is, as explained in this Illustration. The next principle is fossil succession. This principle explains that when a fossil exists or can be found in the same layer have the same age. So in this illustration, this fossil can be found in the upper and these two layers. So this means that these layers are of the same age. And this also. So the next principle is lateral continuity. This principle tells us that even if the layers are cut, it is still of the same age. Just like in this example, it is vertically cut, but it is still of the same age. Next is original horizontality. This principle is basically the same as superposition. So the lower the layer, the older it is, and the higher the layer, the younger it is. But this analysis or principle is important when analyzing tilted strata like this one. And the last one is cross-cutting relationship. This principle tells us that when a layer cuts another layer, this means that the layer that cut the other layers is the youngest. So these are the principles of relative dating. So let us then discuss the principles of absolute dating. So first is carbon dating. Carbon dating is used in determining age of certain archaeological artifacts of biological origin up to 60,000 years old. Next is potassium argon dating. This dating technique is used in determining the age of meteorites, rocks, etc. It can date up to 20,000 to 4.5 billion years old. Next is fission track. Fission track is used in determining the age of tephra. Tephra is what's the volcanic ash called. Next is luminescence. Luminescence is used in determining the age of tephra, lake sediments, or loess. It can date up to 100,000 years. And last but not the least is uranium-lead dating. This is used in determining the age of volcanic rocks 1 million to 4.5 billion years ago. So, in this question, the choices were superposition, fossil succession, carbon dating, and potassium argon dating. Since the question asks about the age of petrified wood, we can conclude that the dating technique should be carbon dating, since carbon dating is used in determining age of certain archaeological artifacts of biological origin. And since wood is of biological origin, it just makes sense that this dating technique should be used. So to answer the question, what dating technique will you use to know the age? The answer should be C, absolute dating, carbon dating. So proceeding to the last question. Question number 9. The diagram below represents the partial inner structure of the Earth. Different layers are represented by 1, 2, 3, and 4. Some depths below the Earth are also shown. Which layer is most likely to contain solid nickel and iron? A. 1, B. 2, 3, C, D. 4. So before we answer the question, let us first examine the Earth's layers. So the Earth has 4 layers. First is the inner core, next is the outer core, Next is the mantle, and lastly is the crust. So, the composition of these layers are the following. So the crust is composed of oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. For the mantle, it has oxygen, silicon, magnesium, and silicates. For the outer core, it's made up of liquid iron and nickel. And for the inner core, it is made up of solid iron and nickel. So with this, we can conclude that the Earth's layer that has the solid nickel and iron is letter D, the inner core. So, if you're still watching at this point, I would like to say thank you for your patience and bearing with me. I hope you learned a thing or two from this lecture video, and I hope that this will be a help to you in the DOST scholarship examinations. Good luck and God bless. Thank you.